When we deal with these multiplication problems involving variables, we have to see the first thing outside the parentheses as being distributed to each of the terms in the next parentheses. So this 6 that's being multiplied outside is being multiplied both by this x and by this 7. Really, I could see it as 6 times x plus 6 times 7. When something's outside the parentheses, it distributes in this way. When I go to do the first multiplication problem, 6 times x gives me 6x. When I go to do the second multiplication problem, 6 times 7 gives me 42. Since they have this addition sign between them, the addition sign stays, and I get 6x plus 42. I can't go any further with this because this term has an x and this term does not, so I can't combine them from there. I have to leave this as my final answer, 6x plus 42. In problem 2, same principle applies. I take this 2 that's being multiplied, I multiply it by the first term, 3x, then the sign between is positive. I take the 2 outside, and I multiply by the second term, 4. When I do 2 times 3, I get 6, and then I have that single power of x. When I do 2 times 4, I get 8, and I keep that positive sign. When I break down problem 3, this 5 is being multiplied by 6x, and this 5 is being multiplied by a negative 1. When I do 5 times 6, I get 30 with that single power of x. When I do 5 times negative 1, I get negative 5. It's perfectly fine also to see this as, well, there's a negative sign here, so we'll really be subtracting 5 times 1. I like it better this way, just so if there's a negative and a negative, I can kind of figure out how to deal with that. But essentially, as long as you come up with this negative 5 at the end, it's fine to see it either way, either as subtracting 5 times 1 or adding 5 times negative 1. In problem 4, we're multiplying by negative 1, so really we have negative 1 times a positive x, and then we're adding to that a negative 1 times a positive 2. Negative 1 times a positive x gives me negative 1x, but I can just write that as negative x. Negative 1 times a positive 2 gives me negative 2. So my final answer would be negative x minus 2. In problem 5, we're multiplying a negative 3 on the outside times a positive 8x. Then we're multiplying another negative 3 times a positive 7. Negative 3 times 8 gives me negative 24 with that single power of x. Negative 3 times 7 gives me negative 21. In problem 6, we're breaking out a negative 9 that's being multiplied by the first term, negative 3x, and adding to that the negative 9 being multiplied by the second term, a positive 5. When I do a negative 9 times a negative 3, a negative times a negative gives me a positive. 9 times 3 gives me 27, and then I have that single power of x. When I do negative 9 times 5, negative 9 times 5 gives me negative 45, which gives me my final answer, 27x minus 45. In problem 7, this is the first time where we have a situation where we're multiplying an x by another x. Specifically, this x that's being multiplied on the outside is being multiplied by this positive x, the first term in the second parentheses. We're then adding to that this x on the outside being multiplied by this 4. When I do x times x, what's really happening is I have x to the first power times x to the first power. When we deal with exponents, we learn that when you have the same base and you multiply, what you really do is add the exponents. So x to the first times x to the first becomes x to the 1 plus 1, or x to the second. That's where this x squared term comes from. Really, there's an understood 1x to the first times 1x to the first, so 1 times 1 gives me an understood 1, which I'm not writing, and then the x times the x gives me x to the 1 plus 1, or x squared. So the whole final term from this first multiplication is 1x squared, or just x squared. In the second multiplication, I'm doing 1 times 4, which gives me 4, and then I have that single power of x. So my final answer is x squared plus 4x. You don't need to do out this exponent math every time in this section because we're only ever really going to be multiplying an x times an x. When you do the first power times the first power, it's always going to get you to the second power. So for instance, when I'm doing this 3x times this 10x, I know it's going to create an x squared term. Specifically, it's going to look like the 3x on the outside times the first term 10x plus the 3x on the outside times the second term a positive 7. I do 10 times 3 to give myself 30. Then I do the x times x, and for the same reason it was above, when I multiply x times x, I wind up with x squared as the variable on that term. When I multiply 3x times 7, 3 times 7 gives me a positive 21. Then I have this single power of x term that stays with it. If it's unclear why this sticks as just the single power of x instead of getting larger or changing somehow, basically what's happening is this is like 3x to the first being multiplied by 7x to the 0. When you don't have an exponent or an x there with that term, the no power of x, it's an assumed x to the 0. When I go to multiply these, 7 times 3 is where I get that 21. If I do this same exponent math, x to the first plus 0 leaves me with x to the first, which is why that just stays as x. So again, the final answer to this question is 30x squared plus 21x. For problem number 9, I'm multiplying negative 2x times the first term x. Then I'm multiplying negative 2x times the second term 11. Negative 2 times an understood 1 gives me negative 2. And x times an x gives me x squared. For the second term, negative 2 times a positive 11 gives me negative 22. The x term times no power of x leaves me with just x. In problem number 10, I'm going to break out a negative 9x being multiplied by the first term, negative 3x. Then I'm going to add to that the negative 9x being multiplied by the second term, a positive 8. Negative times a negative gives me a positive. 9 times 3 gives me 27. X times x gives me x to the second power. For the second term, negative 9 times positive 8 gives me negative 72. I have the single power of x that stays with that 72. So as you're doing these problems, the most important things to look out for is making sure that the first parentheses is being multiplied by each thing, and that you're keeping track of the signs. Anytime that you're multiplying two positives, it can stay positive. A negative and a positive, it has to turn negative, whether the negative's first or second. And two negatives has to turn into a positive.